Hello guys, welcome to a new episode of Leubner's lecture. Today I want to talk about two data structures, two important ones, and these are queue and stack. So there is a requirement for this video which would be basic knowledge about linked lists. So if you do not know what a linked list is or how to implement a linked list, just go to my channel and have a look at the video about linked lists. Good, so let's just start right away. What is a queue? That's a good question. So the usual use case that where you are confronted with a queue is when you go shopping. When you go shopping and you head to the end of the supermarket, you have to pay for your goods. And as soon as you're there, you have to wait in a queue, because there might be people before you, so in front of you or at the back. So you have to wait until you're the one to pay for your goods. But also in IT, we have a lot of different queues. So one important queue is the pipe. So the pipe is somehow used when processes are communicating with each other. There we have a pipe, and this pipe is designed to be a queue. Also, if we have some external devices like a printer, for example, I think that everyone should have heard about the printer queue. So you have a queue where you send your printing jobs to, and the printer prints one document after the other. What else do we have? Yeah, very important thing is a queue is also present for your external input devices. So talking about a keyboard, for example, if you enter something on the keyboard, this comes into some queue and is handled in that way. So if maybe your computer needs some more processing time, you type something and nothing's there on the screen, but suddenly it appears. And then at that point, you see that this is a queue because all the letters appear in the same order that you type them. So let's have a look how a queue looks like. I try to illustrate this here in an easy way. So let's pretend that these are some queue elements that we have. We have the front of the queue here, and we have the back of the queue here. So whenever adding something to the queue, we do this from the back. This is very important. So also, if you pay for your goods in the supermarket, you cannot just go to the and place yourself at the very beginning of the queue. That's not possible. So you have to wait at the end. But on the other side, when removing something from a queue, we do this from the front. And the methods the terms that we use for adding something or deleting something for a queue are special. So for deleting something from the queue, we call this dequeue. And adding something to the queue is called enqueue. Okay, so this is adding something to the queue. Good. When you think about the linked lists that we implemented in one of our videos, I think it's very easy to implement your own queue using what we did there, because a linked list is nothing else. You just have to create two more methods, and these methods are called enqueue and dequeue. Enqueue just adds something at the end of the list, and dequeue always removes the first element in the list. And that's it. You have your own queue implementation. So this principle of adding something at the back and deleting from the front all the time has a special name, and this principle is called FIFO. And FIFO is short for first in and first out. So that makes sense. So whatever comes in first has to go out first. Good. So this is this principle. This is it about the queue. Remember this because there's a big difference to the stack, and the stack is what I want to talk about right now. So a stack is also a data structure and can also hold elements, but there are some differences here. So let's try to draw a stack, and the stack is often just kind of something like this here, where we have different elements on there. And the very important and big difference when it comes to stack and queue is that adding something to the stack is done from the top, and removing something from the stack is also done from the top. That's the very big difference. So remember, with the queue, we added something at the back and we deleted something at the beginning. And here we always add at the top and we delete from the top. You might think now, what is the top? So when it comes to the implementation using a linked list, it doesn't matter. So it can be the beginning, it can be the end of the list, that doesn't matter. The important thing is you always insert and delete from the same side. That's the important thing about a stack. And this principle that we're using here is called LIFO, which means whatever comes in last goes out first. So it's last in and first out. Okay. The methods that we use to put or add something to the stack or onto the stack is called push, and to delete something we call it pop. Maybe in literature you will also read about pull instead of pop, but both of them are valid. And there is one more important term that we're facing with stacks, and this is TOS. And TOS is short for top of stack. So this means this is some pointer, some index, if you're talking about linked list, whatever. But this TOS is always pointing to the first element on the stack, so to the element at the top of the stack. And this is the element to be deleted when pop is called. This is very important. So this is our top of stack here. So the question is now where to use stacks, and stacks are very, very famous when it comes to your operating system, when it comes to a lot of different applications. There are some programming languages that use a compiler, an interpreter, parser, or whatever to parse, compile, interpret their source code, and many of them also use stacks there. But there are two important use cases that I want to talk about more right now. And the first use case is the bracket term or bracket terms. So in math, we very often have terms like we see them on the left-hand side. So some calculations where we have brackets there. So as a human being, we take a look at the equation. We see, okay, what's in the brackets has to be done first. It's 4 plus 9 is 13. And then times 3 is 39. Good. We know this. But what about the computer? Does the computer also know this? No. So therefore, we have an algorithm that does this for us. And to do so, we need some things. We need our term. We have that here. We need two stacks. The first stack is the operand stack, so holding all the numbers. And then we have a second stack, which is the operator stack, holding all our operators. How does this algorithm work? We have to go through our term digit by digit. If we come to some opening bracket, we ignore it. If we come to some number, we put it on the operand stack, and all the operators go to the operator stack. As soon as there's a closing bracket, we have to use the top operator together with the two top operands, apply them, calculate whatever the result is, and push the result back to the operand stack. So let's take a look at the example and try this in practice. So first, what we see is an opening bracket. We can ignore it. Second thing that we see is a number. It's the number 3. So we push the number on the operate stack. Then we have the sign for multiplying something. It's an operator, so let's put it to the operator stack. We have an opening bracket again. Let's ignore it. We have another number. It's the number 4. We push it to the operand stack. So be aware to put it at the top of the 3 because the 4 is now the top of our stack. Then the next thing that we see is the plus sign here. So let's put it to the operator stack, and another 9 that we put to our operand stack here. Okay, so now we have our first closing bracket, and the question is what to do. What we do is we pop the first operator from our stack, which is our plus. Let's put it here and we get rid of it there. And then we pop the first 2 operands that we have on the stack. So this is the 9. The 9 goes here, and then we have the 4. The 4 goes here. And very important, what we just saw is I took the first operand to the right-hand side of the operator and the second to the left-hand side. And this is a rule, and this is very important because this really counts when it comes to subtraction or division, because there it's important. So we evaluate 4 plus 9 equals 13, and the result is pushed to the operand stack, and we are done with this bracket. Now we come to the second closing bracket. So let's just drag it through here. And once again, we put the very first operator from the operator stack. There was only one. Then we pop the first element from the operand stack to the right-hand side of the operator, and the next one to the left-hand side. We have our term here. We evaluate it. So it's 3 times 13 is 39, and we push the result to the operand stack. So now we are done with our term, and at the end, we know that the result is on our operand stack. So our result is 39 here. And that's also what we evaluated as a human being before. Good. So it could happen that you still have more operands and operators on both of the stacks, but that's not a problem. Just apply all the operators to the operands, and at the very end, one result will be there on the operand stack. Okay, I have another more sophisticated example here to go through. If you want to, you can do this on your own first and then switch back to the video, or you just watch and see how this works. So first of all, we have a bunch of opening brackets here. So we just, So we just get rid of all of them here. We don't need them. And now let's start from the left. We have 4. 4 is a number. Let's put it to the stack. We have the plus, an operator, to the operator stack. We have the 8. The 8 goes to the operand stack. So now we have our first closing bracket. So what we do is we push the plus, we push the 8, we pop the 8, we pop the 4. 4 plus 8 equals 12, and we push the result. That's it. Next, we have the multiplication sign here. We have a 2 that comes here. And once again, we have a closing bracket. So let's pop the operator. Let's pop the first operand. Let's pop the second operand. 12 times 2 equals 24. Push the result to the operand stack. We are done. So next operator, we have a minus. Let's put it to the operator stack. We have an opening bracket, ignore it. We have the 12, put it to the operand stack. We have a division symbol here, put it to the operator stack. And then once again for the operand stack, the 3. We have a closing bracket here. Let's pop the division operator here. Let's pop the first operand. Let's pop the second operand. And this is the first time that we find out how important it is to use the first operand to be on the right hand side of the operator. So 12 divided by 3 evaluates to 4. So we put 4 there. Good. And another closing bracket. Okay, so let's pop the operator minus. Let's pop the first operand. Let's pop the second operand. We have 24 minus 4 evaluates to 20, and we push it back to the operand stack. Okay, guys, so ready to go on. We have a plus. A plus comes to the operator stack. We have 3 opening brackets that we just ignore. We have the 5 for the operand stack, a minus for the operator stack, and a 3 for the operand stack. Now we have a closing bracket again. Let's see. We pop the minus, we pop the 3, we pop the 5. So minus 5 minus 3 is equal to 2. This is the result that we push to the stack. Then we see we have the multiply sign again. We have a 4. And we are there with the next closing bracket. So we pop the multiply sign. We pop the 4. We pop the 2. 2 times 4 equals 8. So let's put the result to the stack. We have a plus. Let's put it there. We have an opening bracket, we ignore it. We have some 6 that goes here. We have a division symbol that goes there. And we have another number that's 2 that goes there. So we have the first closing bracket. So we pop the division symbol, we pop the 2, we pop the 6. 6 divided by 2 is equal to 3. And the result is pushed to the operand stack. So the second closing bracket, we get our plus, we pop our 3, we pop our 8, and we know 8 plus 3 equals 11, so we put 11 to the stack. And then we have our last closing bracket, we have the plus once again here, we have 11, we have 20, and our result is 31. We are done with our term, and at the very end, our result is there on our operand stack. Okay, so this is how it works with these terms, with these bracket terms that we have here. And this is a very, very useful way of using stacks here. Good, guys. So there is one more thing I want to show you. This is the so-called postfix notation. So the postfix notation is something that was used, or that also can be used for calculating something with a calculator, or working with calculators. And this is a very special notation. So you have numbers and you have operators, and you have one stack. You put all the numbers on the stack, and whenever there is an operator, you apply the operator to the numbers on the stack, or to the top numbers of the stack. So let's find out how this works. For this notation here, we have the 8. So we put the 8 onto our stack. We have the 2. We put the 2 onto the stack. Now we come to the plus. So we do not put the plus somewhere. we just evaluate the result, and the result is 8 plus 2 because these are the two top values of our stack, and we push the result, which is 10. Then we have 5. We put 5 to the stack. We have the multiply sign, so we evaluate the result, which is 10 times 5, and it's 50 here. Then we have the 9, the number 9, and last but not least, we have a minus. And what we do is we apply the minus to the top two elements. Once again, keep an eye on the order. It's 50 minus 9, which is 41. And at the end, the result is written on the stack. Good. So once again, a more sophisticated example here. We have the 3. Let's push it to the stack. We have the 5. Let's push it to the stack. We have the plus. We apply the plus. 5 plus 3 equals 8. We come to the next element. We push the 2. We push the 4. We have the multiplication sign here. The top elements are 4 and 2. This is where we apply the operator to, and it's 2 times 4 is equal to 8, and we push the result. Then we have the plus here. We have 2 elements left. 8 plus 8 equals 16. Good. Next, let's put the 7. Then we have the minus. So keep an eye on the order. It's 16 minus 7 now, which is 9. Push the result to the stack. Then we push the 2. Then we have the division symbol here. So keep an eye on the order again. It's 9 over 2. So 9 divided by 2, and this is equal to 4.5. Then we push the 6. We push the 3. We have the multiplication sign here. So 6 times 3 equals 18. And finally, we have the plus sign that we evaluate. It's 4.5 times 18. And the result of this is 22.5. So that's what we get. And this is what the result is for this notation. Okay, guys, so these are the use cases of a stack. So the postfix notation as well as the bracket terms. Good, so this is already the end of this session about the queue and the stack. So if you want to know more about, learn more about how a stack or a queue works, you can use the code from my linked list video and try to implement your own queue and your own stack, or just do more examples with the bracket terms or the postfix notation. Maybe you're sometimes asked to, or maybe at some point you're asked to write your own program using postfix notation or bracket terms, and then you already know how they work. Thank you guys for your attention. Thanks for watching my video here. If you liked the video, give it a like, and if you want to see more, just subscribe my channel here on YouTube. Okay, hope to see you again next time. See you. Bye, guys.